Hey, we have here today an interesting integral. This one's from the MIT 2022 Quarterfinals, Round 4, Problem 3. We have the integral from 1 over 2022 to 2022 of 1 plus x squared over x squared plus x to the 2022 dx. And as you can see, they found a way to get the year into the problem 3 times, so that was pretty good. When I first did this problem, I was really messing with the x squared. So you notice you can factor an x squared out of the denominator. You have an x squared in the numerator. I didn't really find a great way that way. It seemed like kind of a dead end with the factoring. Let me know if you were able to factor this or do something with the x squareds. But what I want to notice instead is just these bounds that we have. The lower bound is the reciprocal of the upper bound, and that's going to make me think I could use a u substitution. And the kind of u substitution for this case that I like to do is something like u equals 1 over x. Then just solving for x, we'll notice that we have x equals 1 over u, and we can take a derivative here to get our dx value. Now just looking at this as u to the minus 1 with power rule, our derivative here is going to be minus u to the minus 2, and I'm just going to write this as minus 1 over u squared. And let's just go ahead and make this substitution. So first, updating the bounds. If I plug 2022 in here, we get 1 over 2022, and then with the lower bound, we plug that in for x, we end up with 2022. So it just flipped the bounds. Then in the numerator, we're going to have 1 plus x squared is going to be 1 over u squared. Then again, we'll have 1 over u squared here, and this is going to be 1 over u to the 2022. Sorry, I forgot a du over here. So for our dx value, we're going to have minus 1 over u squared du. Well, I can take this minus sign in front of the integral and use it to just flip my bounds here. So let's put this back. And now notice our bounds are back to what they were in the original. And let's just distribute in this u squared into the denominator. So let's see what we're going to have. I'll just rewrite the numerator as 1 plus 1 over u squared. Then distributing in this u squared here, this term, u squared times 1 over u squared is going to give me a 1 here. Then u squared times this term is just going to be 1 over u to the 2022 du. And then I think for my next step, what I'm going to do is a variable change. What I'm trying to set up here is I want to add this back to our original integral. Like we'll call our original integral I. And so we already have the same bounds on these two integrals, but I want to get back to x, and then we're going to want to get the same denominator. So let's just do the variable change real quick. And just remember that we're always allowed to change the variable to whatever we want in a definite integral, and that's because it's not going to change the value of the expression. Now from here, the only other thing I want to do to add these together is I want the same denominator here and here. And so what I'm going to need to do, sorry, I made a mistake right here. This is supposed to be a 2020, and I'll fix it right here, 2020. So next what I want to do, I want to get the same denominator here so I can add these together. And so what I'm going to do here is I'm going to multiply top and bottom by x to the 2022 over x to the 2022. And let's just see how that's going to work. First, for the numerator, multiplying an x to the 2022, we're going to have an x to the 2022 here. And then multiplying it times 1 over x squared, this is going to be an x to the 2020. And then the denominator, we're going to have x to the 2022. Then multiplying these last two terms, we're just going to get an x squared. And just notice now that we have the same denominator here and here. So I'm going to do the original integral as I. I'm going to also call this one I. So let me just clean up the board and we'll add these two integrals together and see what we have. So we have this 1 plus x squared just coming from our original integral, and then we have this x 2022 plus x 2020 coming from the last board. I just want to focus on this x 2022 plus x 2020. And what I'm going to do is let's factor an x 2020 out of that, and notice that the first term is going to be an x squared, and then the second term is going to be a plus 1. Well, we already have an x squared plus 1 right here, just in a different order. So what I can do for the whole numerator, factor an x plus 1 out of it and write this as x squared plus 1 times x to the 2020 plus 1. So I'm just going to rewrite it with this as our numerator. And now from here, just looking at this piece, I can do what I wanted to do at the very beginning of this problem and factor an x squared out. So if I factor an x squared out of here, this piece is going to become x 2020 plus 1. Okay, but that's really nice because then we get cancellation. We have the same term right here. So now we just have x squared plus 1 over x squared, but that's going to be a really easy integral. So let's just rewrite now with the cleaned up version. Dividing x squared into x squared plus 1, this is just going to be 1 plus 1 over x squared. So now I can just integrate this thing. So integrating 1, we're going to have x. Integrating x squared, that's the same thing as like x to the minus 2. So integrating this with the power rule, we end up with minus 1 over x. We just need to evaluate this from 1 over 2022 to 2022. So plugging in 2022, we're going to have 2022. We're going to have a lot of 2022s. So this first piece is going to look like this. And then for the next piece, we're just going to have reciprocals. So plugging in 1 over 2022 here, we'll have this 1 over 2022. Then minus the reciprocal of that, which is just 2022. Okay, so now we just need to finish this thing off. What I'm actually going to distribute this minus in here to kind of make this clear. So I'm distributing in the minus. This is going to become a plus. This is going to become a minus. And then we just recognize this piece is exactly the same as this. So I'm just going to write this as 2 copies of this thing. And this is almost our answer, but notice we have 2 copies of the integral and 2 copies of this thing. So I'm just going to divide by 2 on both sides. And then we're just left with our final solution, which is going to be 2022 minus 1 over 2022. And again, they managed to get 2022 into the problem just a few more times. So we'll stop it there. Thanks everyone for watching today. Have a great day.